The first four parts first, and then go from there. First one first.
So once you build, in this case, you're gonna have to kind of build your first four terms first, and then look to see, okay, what's gonna be my general term? You know that your three can stay in the denominator, that's always gonna show up. You know it's always x minus two. You just have to figure out the relationship between the changing numbers here. You got that exponent three, and then that numerator is always one more than your exponent. So I can make that n plus one, three to the n times x minus two to the n. So, if you're ever having to build your general term from scratch, after you create what you think is your general term, go ahead and test it out, right? Plug zero in, then plug one, then plug two, and plug three. It should get you back your original term. So I know general term is not a fun exercise to do, but we should be able to check ourselves and convince ourselves whether our general term is going to work or not, right? You just test it out. It takes a little bit of time. It's not a little tedious, but it should be easy for us to know whether our general term is correct or not. And it's important that we know how to build a general term, because a lot of times you're having to do the ratio test on top of the general term that you build. So if you don't have a general term to build off of, then sometimes it really impacts your next sections, because they're not going to give you, if they don't give you a general term and you don't know how to build it, you're kind of stuck in part B. You don't have a function to build your ratio test off of, right? So. Any questions with part A? Uh,
I got the second step, I didn't simplify that. Why did you have to simplify all of that?
no, you don't have to simplify it. You can leave it like that. It could potentially be easier with the next step if you have a simplified version, but you can have an unsimplified that should run. Yeah. But another thing, does it make sense how you get from here to here though? Yeah. Because I just want to just say, let's say this is a multiple choice question. They're asking for the general term, and this is your answer choice, and this is what you got that you can get from here to here. Right? Yeah. Free response, this is fine. They'll give you full credit there. Uh, Part B is only asking you for the radius of convergence, so make sure that sometimes I think on the last quiz or test, I will see some students, they will say that the radius convergence is 1. Make sure that if there's a denominator that you resolve that denominator, get it into the x minus c is less than r before you commit to that being your radius. Um, and also just be careful, especially on the AP exam. I think sometimes we're trained to just always do interval convergence. Sometimes they may not ask you to go that far, so just make sure you reread your instructions and say, wait, they're not asking for the interval convergence. I can just provide the radius. So sometimes they ask for interval convergence, sometimes they ask for the radius. So just make sure that you're providing the appropriate answer that they're looking for. Part C, you're just taking the antiderivative of the of that prime of the polynomial that you built from part A. And g of x is the integral of all these terms, but then there's also plus c. And then that's significant because they give you an order pair, g of 2 equals 3. So you can plug 3 in for your g of x, plug 2 in for all the x's. A lot of the x's should cancel out. You should be able to solve for c. You should be able to get your c value to be equal to 1. Yeah, since if g of 2 equals 3, then c equals 1. Replace 1 and put b. Six. Let me see. Part C becomes X.
Dash x is equal to fx. That's just our general term. It was the derivative or RC.
I don't think we have to build a general term for C, right? We can just build it off of this. Take the antiderivative of each of these terms here.
I don't think we have to do it all, because fx equals g dash x. Now we can split out 3 and 4 is 3 triple dash and 3.
Well, we know that G prime equals F. So basically, what we built in the beginning is our G prime. This is our G prime. Because G prime equals F. So then the antiderivative of G prime will get us up to G. So we just take the antiderivative of this to bring it up to, from G prime up to G. Yeah.
And how did you go to the second row from the bottom where you're putting them two?
Yeah, I'm trying to follow what I did there.
We're trying to force an x minus 2.
I think I was cleaning this up here. Wait. No, wait, no, this one becomes this, one becomes X.
An x minus 2 in parentheses to equal to
Oh, right, yeah, got it, yeah. So I think this is fine, this is fine. Yeah, so 1 plus X is the same thing as 3 plus X minus 2. Forcing that X into X minus 2 gets you into a more, more predictable pattern. But I think any of these variations are fine. Yeah. Yeah.
I'm pretty sure that's also to, I think it specifically says like G of 0 equals 3, so that's making sure 3 is the first term.
Instead of,
But
Yeah,
what's the point of doing that?
Is that like?
did it say that G of
Yeah,
0?
G of 2, or G of 2.
Yeah, G of 2 equals 3. I think any of these variations are fine. This is just a little bit, I guess, cleaner to see the relationship there, but I think this is fine. And then part D, we know our potential interval is from -1 to 5. We can test -1 to 5, neither of them converges, so obviously -2 is outside of our interval. Yeah, thanks for clearing some of that up for us. Any other questions?
Why is it that G2 is equal to C?
So we,
So did you just plug it into the original function as over C? Like,
so this is the original function, or this is the function that we have, right? It's C plus X plus all this. So if I plug in 2 in for X and 3 in for Y, I can solve for C. So I get 3 is equal to C plus 2 plus, and then everything is going to be 0. So if I solve for C, C equals 1. So I can replace C with 1. Okay, let's look at some derivative topics, but any questions from 1 through 4 about either continuity or the continuity conditions or L'Hopital's rule? Yes. Oh, let me see if that was something that. Sorry, it should be -4. I don't know why I put 0. Is that what you guys got? -4? Yeah, sorry. I had -4 here, but I don't know why I went to 0. Yeah. Okay, any other questions? So I'd like to for us to do a variety of problems from page 5 through 8. So can we go through the odds so we can kind of see a variety of problems? And then tonight your homework will just be finish pages 5 through 8, recalling all of our derivative process. So start with page 5. And so a lot of this is either power rule or chain rule or quotient rule or a combination of product and chain. And then when you get to page 6, you have y's in your equation. So there's implicit differentiation involved. You got to involve y's derivative. But yeah, so page 5. Okay, we'll go through the odds in class, but your homework is to finish page 5, 6, 7, 8. Back. We'll just do the odds. Rest of the finish. Be fine for you. That's not enough.
And then the integral of 1 max is out.
The integral of 1 over u du is natural log. That's value be plus. Integral of what?
Be 1 by
Yeah, integral of 1 over x is just natural log s value. Yeah, go ahead and take some. Again, I have your key attached to packet. Should be able to kind of check your progress along the way. Okay, if you're good with 1 and 3, go to the next page. Let's also review implicit. Remember with implicit differentiation, you're going to find the derivative of each term, but if you come across y's derivative, you're going to have to attach dy dx after you find the derivative, right? So y squared becomes 2y dy dx. Y's derivative is 1. We're asking for y's derivative, so dy dx. But you don't do anything different with the x's. It's just y gets its own special treatment since we're finding the derivative of y with respect to x. However many y's are in your original equation is how many dy dx's should pop up in your derivative. I just created a random example. This is the problem. Any questions with 1 and 3?
X over 1.
What you get? You got 2x over 1 minus 2y.
Y minus 1. But yeah. 1 minus 2.
Yeah, that should be the same. The same thing as multiplying the top bond by negative 1. X over y. Yeah, y minus 2y.
Yeah. Oh wait, no, it's y squared.
It was 1, yeah.
So it'll be 1 minus 2.
Like that. Just want to give a reminder for number 7, anytime you see a trig function with that abbreviation exponent location, take the time to rewrite it, especially if there's a derivative or integral involved, especially derivative, because there's going to be a hidden chain rule that is hard to see without pulling that 3 out. So pulling that exponent out. So if you leave it there, there's a high chance that you may not see all the different parts of your chain rule. So anytime you see a trig function and that exponent is in that abbreviated location, pull it outside a set of brackets. That way you can clearly see, okay, I got my outside, I got my middle, I got my inside. I'm just kind of going through each of those parts to build out my derivative using chain rule.
What formulas do we get? Like, do they give us like a formula sheet?
They may give you formulas involving geometric shapes, like volume of a cone, volume of a sphere, but they won't give you any derivative formulas or integral formulas. Yeah, you gotta know all of them. But the good news is that on the AP exam, typically they don't go into the more obscure rules. So it's usually the big rules like power rule, e to the x, sine and cosine, natural log, right? Those are like the big 5. So. Product rule, chain rule, quotient rule, yeah. But typically you don't see them asking you to find the integral of secant or, you know, the derivative of log base 4. Typically that, we don't see that too often on the exam. Derivative inverse at a point. Let me just do a quick review with that concept. It's a very, isolated concept here. So if I have a function, let's say I have a function and its inverse. The relationship between a function and its inverse is the fact that my order pair is going to be flip-flop. So if there's an order pair, comma 4, on 1, there must be an order pair 4, comma 3. Okay. However, there's also a relationship in terms of their slope at their points. Let's say the slope of this ends up being 5. Then this slope here is going to be what? What's the relationship? 1/5. Yeah, so that's the relationship here, is that at their corresponding points, a function and its inverse will have reciprocal slopes. So I like to create a table to kind of work through my process here. If I want to find the derivative of the inverse at a point, I know I can set it up this way. Whatever point they give you, it's always going to be the y value of your original function. And then a lot of times you're working on the original function side to figure out your order pair. Your order pair between the function and inverse will always be flip-flop. And if I can find the slope of the original function, then I can turn around and know that without even touching the inverse function, I know that the relationship is going to be 1 over that slope. So number 9, because they're giving you h prime of -1, you know -1 is the x value of the inverse, but really it's the y value of the original function, since what they give you is the function. So understand the -1 is not the x, it's the y. So if I can use that to help me guess and check my way to solve for x, once I solve for x, which is 1, I can find f prime of 1. F prime of 1 gives me 3. And so therefore the slope of the inverse must be 1/3. Even though we don't touch anything with the inverse, we're using the original function to create that relationship and then just make it the reciprocal. Okay, let's do one more here, page 7, number 1. Homework is 5 through 8, page 5 through 8. I'll send out a reminder in a second. Oh, yeah. Right now we're doing the odds, just so you can see a variety of problems. I want you to do all the problems.